Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the insert interval problem. You are given an array of overlapping intervals where intervals I is start I, end I. They represent the start and end of the ith interval, and intervals is sorted in ascending order by start I. You are also given an interval, new interval, start, end, that represents the start and end of another interval. Insert new interval into intervals such that intervals is still sorted in ascending order by start I, and intervals still does not have any overlapping intervals. Merge overlapping intervals if necessary. Return intervals after the insertion. So if we have 1, 3, 6, 9, and we want to put 2, 5 in there, well, the 1, 3 is going to overlap with the 2, 5, so that's going to become a massive 1, 5 interval, and 6, 9 stays place. This one here, we're inserting 4, 8, so 1, 2 doesn't touch it, but 3, 5 does, so this is going to go all the way to 3, 8, which actually completely envelops this guy, and bumps up against this guy, so this is going to go 3, 10, 12, 16. That makes sense to me. I think the easiest way to do this is actually going to be a rather functional approach. So for I in range len intervals, new, in fact let's call it result, is going to be an empty list to begin with. And what my plan is effectively just start moving intervals over until they collide with new interval, and then do some modifications. So if intervals I1 is less than new interval 0, result dot append intervals I. So if the end of the interval we're currently looking at is less than the new interval start point, then just move it across. So this 1, 2, for example, we don't need to worry about it. If intervals I0 is greater than new interval 1, so now we're doing the opposite end. This 12 extends beyond the 8. In fact, start is equal to new interval 0, end is equal to new interval 1. I'm going to change these slightly to be start and end, because I might want to manipulate these. So, if we're far too early or far too late, don't worry. However, if let's do added as false. If not added, result dot append start end. So if we've gone, if we're off the end but we haven't added this thing, let's quickly add it to our results set. Else, start is going to be the min of intervals I0 and start, and end is going to be the max of intervals I1 and end. So here I'm looking at this 3, 5 business. It overlaps with this 4, 8. So I'm going to say the start is going to be the minimum of 3 and 4. So the start is going to be 3 and the end is going to be the maximum of 5 and 8. So the end is going to be 8. So I have this 3, 8 window that I'm now considering. If we have a look at the next one, 6, 7, well, that's another one there. So we're going to do the same update here with 3 and 8, and it's going to stay as 3 and 8. And then the 8 and 10 window, again, we're overlapping here. So we're going to end up changing this to 3, 10. But then we see the 12, so we're beyond the end now. We haven't added this thing yet, so we're going to add it and mark it as done, and then we're going to carry on to the end. And once we've done all that, we should just be able to return result. So let's give that a quick run through. And it looks like it's working well. Is there anything we need to be careful about? Not massively. This is order n complexity, which isn't bad. I don't think you're going to be able to do too much better. And the reason I say that is because, yes, you could work out where it needs to fit in, say, log n time, or at least where it needs to start in roughly log n time, because you could do a binary search because you know these are sorted by their start point. But you still end up needing to do a whole lot of work to move everything around anyway. Effectively inserting into the middle of a list in Python and then removing pieces, that's expensive. That's very expensive. So here we're just focusing on the end. We're always appending. We're never doing any sort of weird insertion business. Let's see if it's fast enough. Wrong answer. Oh no. Okay. If intervals is in fact, if not intervals, return new interval. That was silly. Should have handled that edge case. Oh, hang on, what have I done here? Oh, at the end here, if not added. That's what I've done wrong. I was relying on this bit here to actually end up adding our new range. But if we never get here, if the last thing we did was to update our start and end bounds, then we're stuck. We haven't actually added it, so I need to do this check here. And that would probably handle this case too. So I don't actually need to worry about that special case. I just needed to handle this more general case. And that did it. That's what we needed to do. In terms of runtime, we're right in the pack. We got a bit lucky on this particular run, apparently, which puts us in the top half. Our memory is completely bog standard. Nothing to worry about there. So I would say this is a roaring success. I'm going to repeat my little disclaimer from last week. Hopefully this video goes up. If the audio is way too echoey, then we'll see what happens. But hopefully it'll be fine. And we'll also see whether my internet lets me upload it. Anyway, thank you very much for watching. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.